All right, we're going to be looking at a quick summary of Chapter 7. Chapter 7 had to deal with similar polygons, and we defined that as two polygons with the same shape but not the same size. And then one step further, that those similar polygons have what we call corresponding angles that are congruent, and then the corresponding sides that are proportional. And so we have three sets of similar polygons here in which they have corresponding angles and in which they have sides that are proportional. And then we have two sets of polygons here that give us examples of polygons that are not similar. If we have similar figures, then we know that we have corresponding angles. And so if we look at these, if we're told that triangle ABC is similar to triangle DEF, then we know that when we go to look at our, we could tell the corresponding angles just by looking at the A corresponds to the D, the E corresponds to the B, and the C corresponds to the F. We can also tell that in a figure, angle A to angle D, angle C to angle F, and angle E to angle B. If we have similar figures, then the corresponding sides are proportional. So side AB would be in proportion to side DE, that's right here. Side BC would be in proportion to side EF, that's right here. And then side AC would be in proportion to side DF, that's right here. And all of those ratios of the corresponding sides are the same. In this chapter, we also talked about scale factor. And so if we looked at the scale factor here, if we look at the green, that would be 8 to 16, and then 6 to 12, and then 9 to 18. And for each one of those going in this direction, we would be multiplying by 2. So that scale factor is 2. So a commonly asked question is, does the order matter? And yes, the order does matter when you write scale factor. The scale factor of shape 1 to shape 2 is 4. And so that means the second shape is 4 times as big. So if you look at the ratios here, if we look at our yellow side, 5 times 4 would be 20. The blue, 4 times 4 would be 16. 5 times 4 would be 20, and then 4 times 4 is 16. So we're multiplying everything over here by 4 to get to this figure over here. When, in continuing on with does the order matter, if we reverse the order and we look at this figure first, going to this figure, we can see that 16 we would divide by 4 to get 4, that 20 we would divide by 4 to get 5, that 16 we would divide by 4 to get 4, and that 20 we would divide by 4 to get 5. And so their scale factor when we go from this figure here to this figure here is now 1/4. In this example, we can use the idea of proportional sides to be able to determine the perimeter. So we are told that in this particular example that we have triangle ABC, and that is congruent to triangle DEF, and we want to use that to be able to find the perimeter of triangle DEF. And so when we look at this, I could see that in pink here, I'm given this measurement here as 6 inches and this measurement here as 9 inches. And so when I'm thinking about what that scale factor is going to be, that's 6/9. When I simplify, reduce it, is going to give me 2/3. And so I can now use that if I know that that is the proportion of the sides. And if I know that I have this side over here that is 10, and I'm missing this side over here, and I check my correspondence that A to C would correspond to DF, then I could take and say that that is going to be 10 over X. And so I could take and say that this is going to be 2x equals 30, and x will equal 15, and I now know that that side is 15 inches. Now I can keep the 2/3 right there, and now if I look over here, I see that I have this as 8 inches, and that is going to be proportional to this side over here that I don't know, but I can take and put the 8 over here and the x here. That is going to give me that 2x is equal to 24, which is x is equal to 12, which then gives me the third side of that triangle. And I now can take and figure out my perimeter by adding the 15, the 12, and the 9, and that is going to give me a 36. So therefore the perimeter of triangle DEF is 36 inches. The next part of the chapter, we started into looking into our similarity postulates and theorems. And so if we look at what we have here, here we have what is we call our angle-angle similarity. And so angle A corresponded to angle U, and angle M corresponded to angle T. And if we have two angles that are congruent in a triangle, then we are going to have similarity. So triangle AMJ, so remember the naming of these are important. So AMJ is similar to triangle UTO, and that would be by angle-angle similarity. Our next similarity postulate looks at us having two sides that are in proportion. So if we look here, 4 to 6, if we reduce that, that's going to give us a 2/3. And then we have 8 to 12, and if we reduce that, that will give us 2/3. So our sides are, we have two sides that are in proportion, and then we have a side that is congruent. So we can say triangle ABC, and we want to look how it's named. So from A to B to C, and then over here that means that we would start with angle F and go angle FE to D, and those are similar by side angle side similarity. Our third similarity process is postulate is side side side. And so if we look at this, we have marked off in pink here the 5 to the 10, which is 1/2, and then 8 to 16, which is 1/2, and then 11 to 22, which is 1/2. And so then we can say that triangle ABC, and notice how when we go ABC, if the coloring helps you, notice how I went from past pink to blue to green. Then over here this would be similar to DEF.